Welcome to another edition of the Sim Racing Garage. I'm Barry Rowland. In this episode, I'll be doing part 1 of a 3-part review series on the PT Actuator 5DOF motion system. This video will cover everything that is required to build the motion system chassis. Part 2 will cover all the electronics you will encounter during your build, with part 3 being the actual tuning and testing of the PT Actuator 5DOF system. Time to put this system through the SRG's review process and see how it does. So, let's get to it. Here are all the parts laid out, so they're ready to assemble. Of course, we have some back here too. And they came in a very good shipping package. All the profiles, you see we have a bunch of profiles back here. A lot of profile, actually. Because remember, we have 3 actual different sections we're going to be building here. And yeah, the profiles and some of the other stuff came in a nice wooden crate. And everything else came in some boxes that were very well wrapped. Yeah, made the trip like a champ all the way from China, so real happy with that. Nothing got dented or scratched in transit. And of course, you can see we have a lot of parts here that we're going to be using to put this together. We have of course, the actuators over here. And these are the 4 main actuators. And you can see they use this mesh to ship these in. Now, this one I've actually opened before, about putting the mesh back on for protection. But they do the plastic wrap and then put this nice nylon mesh on here. So very nice protection as it's being shipped. So we've got our 4 main actuators over here. And these 2 right here are going to be for our yaw and our surge. And of course, lots of hardware and plates, the things that we're going to be using. We've got our cable sitting up here. We have a custom stop button that Shao from PT Racing made for me. Got the little SRG logo on there. Pretty cool, huh? And of course, we have our servo drivers over here that we're going to be using, the AASD 15As. And yeah, these are very commonly used in building these kind of systems. So I just thought I'd give you guys an overview here of all the goodies we've got. And we also have this guy that's going to be our interface, which is a very cool controller here, the AMC AASD controller. Give you a little better look at it there. And we're obviously going to be looking very closely at this and how we're going to be employing it, the Thanos controller board. And we can actually do 6 servos over here, and we can actually do another servo over there if we want to do like a seatbelt tensioner or something. So yeah, there we have it. Now, all we have to do is get it all built. Because there's no real instruction manual how to assemble this system, I thought I'd show you guys in 3D in my Fusion 360 viewer some step files that you can download from PT Actuator to see how this thing is built. Now, there are some PDF files on the PT Actuator website that you can download, and they're essentially parts lists with some drawings on them. So easier to see how it is going to be built through these 3D renderings that's also available from their site, I think. And you can see we have the traction loss platform here. So if you ordered a traction loss platform, you would obviously have 4 actuators and the other actuator, the yaw actuator down there. You can see it right in here. And of course, I have one to show you for the surge that we have on the system that we're building. And that would be like this, but it's very complicated. And at this point, we don't need all that. And we will get to that part of the build, or we'll start looking at that once we get to that part of the build. So, and we'll go over just what we're interested in each one of these little segments. So, right to the point here. This is the bottom frame, or the base assembly, if you will, that these rollers and the actual moving yaw platform is going to sit on. And it's also holding a box that will hold our servo drivers. Those boxes, you can see them underneath there. But we're really interested in here in how we're going to assemble this basic frame here of 80/20 profile. So on the top, in the bottom here, in this orientation, this is where our longitudinal profiles are going to be located, and they are 1400 millimeters each. So we have 2 1400 millimeters. Then we have these other 4080s that are crossing up and down perpendicular to that, or in the vertical position here, and they are 820 millimeters long. So those are the spreader units, okay? And you can notice we have some 40 series in here also. You can see these guys here that are supporting our servo drivers, and of course the housing, this metal housing that they have for this, which is great for shielding, by the way, EMI shielding. And we have 2 more 40 series that are 200 millimeters long over here. I also want to pay attention to the brackets that we're using. And if you'll notice on the furthermost back profile, 4080, and front, that we have some larger brackets than all the rest of the corner brackets. So we have these large corner brackets on the very corners of the ends of this frame. So that's where you want to pay attention to. One of the things, obviously, the orientation of those. And the rest of these corner brackets are pretty self-explanatory. They are just the regular ones that I will show you in the parts list when we're actually building this. And I'm going to zoom in a little bit here. If I can pan this in. Well, I'm going to pan it first. See if I can zoom into this so you guys can see it. Oh, going the wrong way, zoom. Pan it down. And this is what these corner brackets are looking like. Let me go back to my orbit. And you can see, pretty simple here. We have two on the insides of these spreader pieces, which are, by the way, 760 millimeters long, these 40 series. And you can see that we're using bolts and nuts. And I'll show you that in the hardware. There's a little bit different system for attaching these pieces. Not too complicated, obviously, but just a different system. So now let's go take a look at the hardware on the bench. Before I actually build the base assembly of this motion platform, I wanted to go over some quick things with you guys about the profiles and the hardware we're going to use to attach this with. First off, this is the PT Actuator profile, and it is a standard 40 series dimension. This is a 4080 because there's two of them. And again, a standard dimension everywhere except one place. The channels in here are deeper than a normal, or what I would call an industry standard channel, as far as at least over here in Europe and North America, because everything I get from here and there has a shallower channel. And this is a 40 series, what I would call a standard 40 series, even though it's a light because it's got some of the metal drilled out around here. Look at the difference in the depth of these channels. Let me get them together here so you guys can see them. And it's pretty easy to see that the PT Actuator one is definitely deeper, right? Other than that, it's the same. And the only other non-standard, obviously I would call non-standard profile, is this one. And this is a JCL profile you may have seen if you watch some of the JCL stuff that I did on reviews. And this one is the same depth as the 40 series, regular 40 series, which is this guy over here. Exact same depth, but the channel itself over here is wider, right? And that means the T-nut that fits in that channel properly will not fit in the regular 40 series. But a 40 series T-nut will fit in this one but it's a little sloppy because it's wider. All right, but it's not deeper. All right, so just want to show you what the differences are there. Here's the hardware we're going to use. First time you guys have seen me use these, this is what they call a drop-in stud T-nut. That's what it looks like. M8 thread, because there's a stud there, and then we have the T-nut shape there. And this T-nut shape is a little unique in that this has a bevel over on this side, and it has a bevel on this side on the bottom. But on here, it's straight, and on the bottom over there, it's straight. And that allows us to put these in and turn them clockwise, and they lock into the channel. Like, there it is. All right, so you just put them in, and we rotate it, and it locks in, just like that. And then it will come out. But if you notice, when it's sitting there, it's kind of wobbly. It's not like the roll-in spring T-nuts that you guys have seen me use so much. They can be a little fiddly, but they do get the job done. And you can still get them into an open slot if you have it closed off. Like if I had a piece of profile this way and this way, I could still drop this in here and put something on it. Or if I could do this with these brackets, and I'll show you these brackets. First, I want to do this. You just drop it in like that, and then you turn it clockwise. It'll tighten up. All right. But again, it's a little bit fiddly if you just put the stud in, and then you got to put whatever you're going to put on. Like if I had a bracket and I put it on there, it's still doable, but it's just not as stable as the spring ball T-nuts that you roll in. And if you turn it sideways, then things get a little more interesting, right? Because down flat's easy, but when we're like this, it's a little different. So, but of course, this is completely doable. I'm just showing you the differences. Let's go ahead. I'm going to need you. You stay right there. So here's the brackets we're going to use. These are the small brackets, and they have slots in them instead of holes. See that? Very long slots. And the reason is because we pre-assemble one of these guys, the stud with the nut on it. And by the way, the nut, I can show you that, has teeth on it. It's one of those locking type of nuts. You put some torque down on this and it bites into the metal. Usually it's good to go. It doesn't come loose. And you put one together like this. And with this bracket sitting here like this, I can just go ahead and drop it in through the slot, turn it clockwise, and it should lock down. Like that. If I got it in, there it is. See, pretty easy. And I could already have it in the bracket and do the same thing, because when I turn it counterclockwise, it comes right out. So I could already have it in there like this and drop it in and do it, right? So that'd be a little bit quicker. And then you just gotta kind of twist it around a little bit until it gets free, and there it goes. And in fact, it comes all the way out of the bracket again. Now here's these big brackets. If you saw the 3D rendering section I did just before this, and showing you how we're gonna build this and where all the parts are supposed to go, this is a little bit different. It has a slot there and it has a hole here. So these we have to pre-assemble at least in these holes, because obviously this T-nut is not going through that hole. It's just going to sit there like that. So we have to put them in the holes, and I'll use this as an example. And these are the big brackets that are going on each of the corners, the outboard corners on the front and rear 4080 series profiles that I've talked about before. And you'll see that as I build it too, and show you the finished product, or after we build it. So this one we're going to leave in like this, but it's still pretty easy to use this, because let's say I want to do what we're going to do over there, and I want to take this and take remember we got two 1400 millimeters for the sides that run the length of the cockpit. We've got some 820s crossing over. So I'm going to be assembling those together. That's the best way to show you this, would be like this, I guess. So I would take my bracket that I've already got these things screwed into. And one more thing about these, because of the depth of the brackets and clearing the channel, you need to have your nut about flush with the stud, or a little bit over the stud and flush, for it to be able to reach down far enough and twist in and grab that channel. Because if you have it even down like this, a little bit protruding, it won't get it's not deep enough. So it's very close tolerances here. All right. So I will put these two pieces like this. That'll come in with my corner bracket, and because they're already in the round holes, just set it down like that, push it in over there, push that one in over there, and then I could just tighten it down. Again, turning clockwise. Right? And then we come in with our pre-assembled studs and nuts. And remember our slots down here? I just push it in the slot, making sure I have plenty of room so it'll engage, and then go ahead and twist it counterclockwise and get it to engage. And there it goes. All right, so that's how we're going to do it. Pretty simple, really. It can be a little fiddly if we're working in the, a direction where gravity is pulling down on that stud. But because we have the kind of brackets we have, we can actually just push everything through it and then turn it clockwise. So it shouldn't be that different or difficult. Anybody should be able to do this, obviously. It's just another way of constructing with profile. I just want to point that out to you before we go over there and get on the floor and put this thing all together. Now I have the base assembly laid out in the way it should be, and as you can see, we have the 1400 millimeter rails going up the sides here, and we also have a little piece of dirt on there, the 120 or 820 rather millimeter crossing sections that are also 4080s. We have our 200 millimeter 40 series there, and we have our 760s right here that is actually going to hold our servo drivers. And as you can see, I've got one servo driver on here already as a mock-up, using it as a template, if you will, so that I can see that it will fit those crossbars, because obviously we want to make sure that it fits. And yeah, the big wide brackets are on the corners here, the out-facing corners, or the outermost corners of this configuration. We got them down here too. And as I explained before on the hardware, it's just a simple matter of getting these things to line up like we need to. And I'm going to get down here, a little close up here. And you can see the big bracket. I've already got it pre-assembled in the holes, and I'm leaving the slots open on this so that I could just kind of press this in, or push it in, not really pressing it in. And then I can turn these and get them to hold the bracket where it needs to be, just with hand tight. And then I'll take these guys and push them in to the slots and turn them clockwise. And the same thing happens. And I'm also going to show you on the smaller corner bracket, or what I would call the normal corner brackets over here, do the same thing. We've pre-assembled our stud and our nut, and just going to push it in to the slot like that, and start turning it clockwise. And there it is. All right, pretty simple, huh? So we're going to do that to all the brackets in here. I'm not going to cinch them down just finger tight because there's some adjustments I might have to make to accommodate the plates that the yaw roller wheels are going to be riding on, and they have to go on top of here. So we want to make sure once they go on top of here, it's going to be hard to get to these nuts. So we want to make sure we get everything lined up right before we actually cinch it down tight. And yeah, we'll actually go ahead and do that, and then we'll take a look at the results after I'm done. So I have everything assembled now as far as all of the studs and nuts. And yeah, there's a lot of them to do here. But if you take your time, it's not that big of a deal. And also, I'm showing you a little clip here. If you get an extension with a 13mm socket on it, it makes it a lot easier to actually screw these things in than trying to use your fingers for all of them, because you can see there's quite a lot of them to do here. And that just speeds things up and makes it easier on yourself. Right, so we've got this done. All we have to do now is get the landing plates on top of this frame. And I'll show you the landing plates and what they look like and how we're going to install them next. Now we'll use our 3D rendering again to look at these front and rear landing plates. I'm calling them wheel landing plates because, well, they're just plates that the wheels are sitting on. So there you go. And let's see. Let's go ahead and flip this around backwards. First, we'll look at these three back ones. So we have three wheels here. We have a center plate supporting that center wheel. And that's pretty much self-explanatory. It's just gonna line up in between these two back plates. Now the back plates are the bigger ones. But the thing about the back plates is they also have these 200mm crossing pieces that we put in here. These 40 series 40 200mm long pieces. They're there to actually support the frame a little bit, I would imagine, but also to catch one of the bolts for these rear plates. And I'm going to see if I can get this in a little closer for you. There it is. So if I turn this around, you can see that bolt there is not in the rear channel of that second 820mm long 4080 profile. It's actually in that 40 profile that's crossing back and forth here. And that's really the only one that goes in that. The rest of these are going into the 1400mm long profile and the 820 crossing across the back. So just something to be aware of. And the spacing on this, as far as getting it to match up where that plate hole is just something that you're going to have to do as they slide back and forth pretty easily once you loosen them up. So it's no big deal getting them lined up. And once you have them lined up to where the bolt holes will fit in these channels, then the rear plate is just going to line up. It goes in between them. There might be a little gap between this long plate and these side plates, but no big deal because that wheel's not going to go any further than those bolts. In fact, if it does, I've actually tried it, it actually hits the bolt. So it's not going to go any further than that. Now the front, again, couldn't be easier. This is the other plates. They're the smaller plates, and they're in let's go ahead and get out of this a little bit. They're in longer than wider configuration here. So, it's easy to see that. You just flip it around, the plate around until the holes line up with the rear channel in this 4080 piece that's 820mm long, and in the very front groove on the other 4080 piece. So easy enough there. And then you bolt them down, you're good to go. So yeah, you shouldn't have any problem with that as long as the spacing is right. And if you put your bracket in, it should be right. As far as let me go back around here, the bracket that's going to support the bearing pin, the pivot pin in there, if that bracket's on there, then the rest of the stuff lines up perfectly because all the holes on this bracket will make everything else line up. So pretty easy here. So yeah, let's go ahead and get these plates on. Here are samples of the landing plates, I'm calling them, for the wheels that we're going to be using to provide our yaw motion. And these are 1/4-inch thick steel plates that look like they have the same powder coating on them. And yeah, we're just got 4 holes. We got 2 here, 2 here, and we saw in the 3D rendering that I just showed you before this how these are fitting on. We have a smaller one here, and this one is a little bit bigger. They're the same width, but you can see that this one is actually wider. So the wider ones go on the rear of this assembly, and these smaller ones go on the front. We also have this one that's going on the back for the third wheel. It's in the middle for the rear of that yaw action. And yeah, this is just a long plate that's going to support that guy. And here is the bearing plate that I talked about. And we have, this will span the two 4080 profiles, the 820mm long ones on the front. And then we have these 4 bolts left over here that are actually going to hold the pin for the bearing. In fact, I'll go ahead and show you that pin. It looks like this. All right? And the bearing, and I'll keep this off right now because I want to show you how this bearing and the pin work together once we get to that point. So yeah, let's go ahead and get these mounted up and see what they look like. So the plates are now attached, and one thing I wanted to point out, well, a couple things, is that these 200 millimeter pieces of 40 series, the 4040s, they need to be in line with this other bolt over here because this plate does not fit over into the back channel here of this 4080 piece that goes across. So both sides here, we had to realign a little bit this 4040 piece so it would catch that bolt, and then you're good to go. And really the only other consideration is this is not a perfectly square piece here for the fronts, so you will have to turn those so they're long this way and not that way for this to work. And probably the last thing I want to point out is this bearing mount, or the bearing pin mount. You want to make sure that this is centered on the frame, on that side and over here to this side, which came out to be 490 millimeters dead center. So you want to make sure you have that center, obviously, because that's going to be our pivot point for our yaw function or yaw element that is on this chassis. Other than that, yeah, everything is great. Looks good. Everything is nice and tight now. Very solid frame. And I think what I'm going to do next is set up the mount for the yaw actuator that's going to go across this piece right here. All right, so we're going to have a mount somewhere over there, and we'll take a look at that before we actually start attaching it so you guys can see what that should look like. Now, before I start putting on these actuators, starting with the yaw actuator, we already got the main frame built. Now it's time to decide what I'm going to do as far as setting it on the floor. Obviously, it's already sitting on the floor, but I'm not going to leave it just sitting on the concrete like that. PT Actuator does not ship these kits with feet, and the reason is to try to keep it as low as possible. They do have a mat available. I did not get that, so I kind of came up with my own solution here. Now, again, they have feet and they have rollers that are available as options for this. I'm going to try to keep this as low as possible. And of course, if you're mounting or building one of these on like carpet in your gaming room or something, then you just go ahead and build it on the carpet and you're fine. If it's on a wood floor, obviously you need to do something different. But on concrete, I'm going to be using this stuff here. And this is a very dense foam that if you pinch it in just one spot, it flexes pretty good, right? And this is a heavy duty yoga mat material. But if you put something like a profile on top of it, and it's got load bearing all the way across in this way, the length and the width, then yeah, it doesn't compress very good. Even when I stand on it, there's no compression here. So it does very good as far as load bearing when you have this kind of load on it all the way across. But when you just put your finger on it, you can push it down pretty easy. I guess it was made that way on purpose. It's about 13 millimeters thick. And again, you can see this very dense cells that it has in the foam here. Now, I'm not sure 100% this is going to work. It may get squished once we get about 500 pounds on it, but I'm thinking it just may, because I'm going to have a piece of this under all the profiles. The long 1400 millimeter profiles, the 820 millimeter crossing or spreader profiles, and even the 40 series profiles underneath. I'm going to be putting this under there. So it'll be sitting on this, and just on these slivers, though, I didn't see any point of putting the whole thing underneath it. And not only that, but it wasn't wide enough. So without further ado, I'm going to go over here and set this on here, or set the base assembly on these pieces, and we'll see what that looks like. I have the mats placed underneath the frame now, and you can see that it's still not all the way level with the concrete floor, because I can wiggle it a little bit. But I think as we add weight to this, it's going to be compressing everything like it should. And I've actually stood up on this just for a test and tried to get it to move sideways or just to slide. And with my weight on it, it wouldn't slide. So I'm pretty confident this is going to work to keep things from sliding. Again, I won't know for sure if this foam is going to be able to tolerate the pressure I'm going to put on it, but I'm hoping, because the load is a bearing load all the way across these long pieces and the crossing pieces over here, that it's going to work. So we'll just have to wait and see, won't we? here are the parts that I'm going to mount on the base that we've already built to support the traction loss element or yaw element. And I'm just going to show you the parts here before we put them on. And of course, we're going to be building a whole separate assembly to set on top of the base assembly that is going to actually have rollers on it to perform the yaw function. Now, first off, we have this massive pin here. It's a steel pin with a big flange on it. And I say it's massive because it's pretty big. All this stuff is pretty big and heavy duty, very industrial. And this is 28, a little over 28.5 mil, right? Thick. And it feels very substantial in hand. Nice powder coat finish on it. We have I believe this is an 8 mil or so flange on here. So we got there, yeah, 8.3 inches on the flange. And yeah, just a very nicely done piece here. The powder coating's very nice on it. And it has a nice ring to it. All right, so we also have this mount that we're going to be mounting this actuator to. And I really like this mount because it's a well-engineered piece that was well thought out on as far as the function of this actuator and what it's doing. And it's a bearing, it has a flange on the bottom here that we're going to be mounting to our 4080 pieces, right? And it has obviously another flange here that's a U-shaped flange that will mount onto the actuator itself. Actuator has, I think you can see the holes here. Where are my holes? There they are. 4 holes. And of course on each side there'll be 4 holes. And instead of just making this a bracket with some holes in the bottom of it and just attaching it to the profile, they went the extra length to put a bearing in here. See that bearing? Well, you can see that. If we can get a little focus here, it'd be nice. There we go. Okay, there's the bearing. And it's a very precision bearing. The whole assembly is very nice. You can see how easy that spins around there. And the reason they're using this is because when this yaw actuator is moving the top back and forth, it's actually moving it, it's actually kind of swinging in an arc because obviously it's pivoting on our pin here. So there's a bit of an arc to that movement. And this allows the actuator to move with that arc a little bit. So it doesn't bind up while the arc is moving. Very, very nice the way that they've done this. And another testament to the good engineering in this system is they've actually put a hole in there, so we can mount this to that profile without any dramas. No, I have to take this apart and mount this on and then put it all back together. They put a hole in there so that we can mount a bolt there. Then when you go to your next bolt, you mount that one, so forth and so on, all the way around the flange. Very cool. And like I said, I really like it when the engineers think through about all the problems that we're going to have as far as mounting things. And it's just like I said, it's just a testament to they know what they're doing. Right, so let's go ahead and get these parts installed. Now I'm attaching this heavy-duty bearing pivot pin assembly or flange so that the bearing can obviously have something to hold on to as it pivots. I've got 3 of these bolts in already. Now these are just simply, and they are in your kit obviously, a 25 millimeter long M8 bolt, socket head cap bolt. See that? And of course you can see I got a little washer on here. And we just slide that in. And they provide us with these M8 nylock nuts that have that nylon locking material in there. And just hold it underneath. And get it to where it started good. Of course, we can't turn it but so far anyway, because we need a little power or effort to get it to turn more than that. And we have a 13 millimeter wrench under here that I'm going to use to tighten them up. I'll do this, I'll probably mute this so you guys don't have to listen to it. Then once we're done with that, I'll go ahead and go back. Just give it a hand turn instead of a machine turn, just to make sure I feel like I've got it torqued down enough to where it's not going to go anywhere. Of course, with these nylock nuts, you usually don't have to worry about that. They do a good job right away. And I don't torque down so much that I'll snap it. I just want to make sure that it's good and snug, as they say. That'll do. Right. So there you have it. Now we're firmly attached. I'm installing the bearing rotating bracket for the traction loss actuator now. And I've already got some of these T-nuts in here, but I wanted to save one to show you guys that this is a different kind of spring T-nut, if you will. It's not the spring balls. This has a piece of spring metal spot welded to it. Let's see if I can get you guys a good look at it there. See that metal right there? A little bit closer, and it's got some spot welds in it. I think you might be able to see that there. So instead of a spring ball that's captured on the bottom, that's the springy part. So these are pretty easy to put in. They can be a little fiddly though, because they'll turn on you and then you got to fish them back out. But once you get used to it, you can pretty much slide them in pretty efficiently. And you want to slide it in, you want to collapse that spring. You want to collapse that spring tab as we're pushing it in. So I'm just going to go ahead and push this in like so. Snap it in. And then I keep pressure down on it as I use my fingertips to kind of walk it back towards me so I can get it to seat in the groove of the channel. And there we go. There we go. So it works the same way as a spring ball, but it's just, like I said, it's a little bit more fiddly, or it can be, but once you get used to them, it's not a big deal. Now the flange here goes on a certain way, all right? So that it will span, I don't know how well you guys see this, these holes can go this way, so they'll fit in the channels. But if I turn it around the other way, they wouldn't fit, right? So just make sure you get it lined up, and it'll relieve your dramas of installing this bracket. And of course, remember, we had the hole here in this bracket. See our hole up there on the top part? So we can just drop our bolts in. There it is. Drop our bolts in, then move to the next one. Okay, so let's go ahead and do that. And these are M8 15mm bolts. Socket head cap units. Stainless steel, very nice. And I'll just line up the hole here with the thread and just kind of drop it in there. Then I'll take my 6mm wrench, or driver wrench, whatever you want to call it, and just get it started. If I can get it started. There we go. I think that's it. And I'm not gonna get it fully tightened because I want to be able to move it around. So then we'll slide this a little round here, and then I'm looking down the hole again, straight down, so I can see where the threads are, and just kind of drop it in there and do the same thing. And you don't want to push too hard when you start these bolts. You want to be easy with them, because you can push it down on the T-nut hard enough to where it'll push it down and out of the groove, and that's not what you want to do, because then you're going to have to fish the sucker out. And that just takes more time. But you can see it's not a big deal here. He's going pretty good, actually. And this hole in here is just genius. It really saves you a lot of time. Well, otherwise, I would have had to disassemble this unit, bolt the bottom part on, and then bolt everything back together. So yeah, they save us a little time here by doing it this way. Now I'm not sure where I'm going to be yet with this bracket, right? So I'm going to leave it loose so I can still kind of slide it around a little bit before I mount it in there. So what I'm going to do with that actuator is I'm going to pull it out 3 inches, or half its travel of 6 inches, or 75mm from where it's totally closed. I'm going to bring it out 75mm, and then I'll get a better idea of where it needs to be sitting. And again, probably I'm going to have to wait till I get the yaw frame on here to get a final fit for it. And a matter of fact, I think what I'm going to do is just leave the actuator off at this point and wait till I get the other section built, and then we can put it on and get a much better idea of where that bracket's going to line up on the side. But we'll talk about that when we get to that point. We're back in Fusion 360 to take a look at the traction loss assembly that we're going to be building. And this is going to be a much simpler assembly than the base. You can see it's just the long 1400 profiles for the length of the cockpit. So those will remain the same length as what we used before, but we're using the crossing members here. They will be 660mm, and we need 3 of those. And you can also see that we have the big brackets. Let me push this back a little bit so you can make sure everybody can see this. The big brackets in the back corners and in the front corners. And then we have the smaller ones, just like we did on the base assembly on everything else. So we have 4 of those smaller ones in there. Then we're going to be attaching the landings, the non-captive landings for our actuators on top of that. And on the bottom, get a little closer here. On the bottom, we're going to be putting the wheels, obviously, and we'll see how those go together. And the bearing plate. See the bearing plate there? And the plate that will support the bearing plate. That is the same plate, as far as dimensionally speaking, as the bottom plate that's holding the bearing pin. All right, pretty simple, really, comparing what we've already built. And one more thing, we're going to be, let me scoot this over, taking a look here at how we're going to mount the yaw or traction loss actuator. And you can see there is a bracket up here that we're going to be using against the profile. And then we already have our bracket on the base plate there. And once we have this sitting on top of our base plate, then we can decide exactly where this bracket for the traction loss actuator needs to be located. And we're going to have that extended a little bit, about halfway, so 3 inches out or 75 millimeters extended. So it's centered at that point, so it has equal distance of 3 inches to go either way, whether we're yawing to the right or to the left. And all that'll make more sense once we have this assembly sitting on top of the other one. So let's get to it. The traction loss frame is now fully assembled. Well, not fully assembled, but close to it. And I did put the bearing plate on, and I made sure that this bearing plate is centered on the width of this frame, which is 820 millimeters. So the very center of that hole there is right at 410 millimeters. So all things being equal, we did center the bearing pin, the receiving pin over here, and make sure that was centered. So like I said, if it's centered there and it's centered here, once we have it on that pin, then everything will be lined up perfectly. That's the theory anyway. So let's go ahead and again, the assembly of this frame was just like when we did the base over there. So yeah, no new techniques or anything to show you. And we do have the smaller corner brackets on both sides of this piece behind the front piece, just as a let you guys know. And then we have the big brackets everywhere else. Right, so what we're going to do now is take a look at the bearing and the wheels we'll be putting on here. This is the traction loss pivot bearing assembly. This has a really heavy metal flange around this bearing, just heavy duty stuff, like the rod ends on the actuators for traction loss and surge. It's just big, beefy industrial stuff. Anyway, you can see the bearing. I'll show you the number of it here, in case you guys were wondering what kind of bearing they're using in here. But you'll notice it also has some set screws. Turn this around. There's one. There's the other one. Or grub screws. You can see the holes inside of there that allow us to turn these in and grip the pin that's going to be sitting in here. So make sure it doesn't slip and does exactly what it's supposed to. It gives us a very smooth traction loss action. This is also a bearing that can pivot inside the housing itself. Check that out. So yeah, no binding on this bearing assembly at all. And this is really hefty stuff. It's, what is it, 2 pounds and 5 ounces for this, and just over 1 kilo. So yeah, very nicely built, heavy duty stuff. It gives me confidence that, yeah, it's going to be able to take the punishment that these actuators, I think, are going to be able to dish out. And this little yellow dot here is actually a plug that is plugged into our grease port. So we can actually grease this once it's mounted. And it comes with a little grease fitting like this. It's got a little cap on it. I think I can just go ahead and screw that in there. Yeah, there it goes. And I'll tighten it down with the wrench, of course. So once it's in, I'm going to orient this so this grease fitting is towards the front when it's hanging down like this, towards the front of the rig, so I can get in there easily with a grease gun and grease it if it needs it. Very, very nice assembly here. Yeah. And we're using these huge M10 stainless steel socket head cap bolts, and that is an 8mm hex on the top of that. And we have some washers we're going to be using on it, and we also have these nylock locking nuts that are also M10s, obviously. I believe these are 15mm inside for the wrench. And yeah, so again, all heavy duty hardware to be mounting this bearing. So we're going to go over there and get this baby mounted. The traction loss bearing and housing is now installed, and it is exactly centered in between the two sides, which it was 410mm, I believe. And that should fit right once it fits onto the pin over here. That should line everything up perfectly as far as left or right of the base assembly we've already made. So everything should land where it needs to land. So yeah, and I do have the grease fitting in there in the front, so if I need to grease this thing, I'll have easy access to it. So yeah, very heavy duty stuff here, guys. Yeah, this is, like I said, it instills confidence to have something like this on here. Here are our traction loss wheels. They're going to allow us to pivot around. And this is a nylon wheel here, rolls very freely, and it has a steel assembly here, as you would expect for this kind of duty. And it has the bearings inside there. You can see the ball bearings there. So this is going to be obviously a lot of weight on this when it's moving around, so it should roll pretty smoothly, I would imagine. And it's neat that they've And these flanges are made in-house over at PT Actuator. This is a flange that adapts the wheel, obviously, and its little flange that the wheel comes with to this aluminum piece that's been tapped and threaded, or drilled and threaded, actually. And we're going to be using some socket head cap bolts to mount these that we did some other mounting with. If you saw the traction loss actuator bracket, we did the same thing. And these are what we're going to use. These are M8, and they have a 6mm head on them, socket head cap. It's not stainless steel, very good stuff. And you can see the machining in this plate. There is a little shelf in there, see that? That this socket head will go down, and nice and even. Very nicely done there. And we're going to use these spring nuts, or not the spring ball nuts, but the actual spring nuts that have that spring that we saw before. It's flexy, and we kind of just take this and roll it into the channel, and gives us that M8 T-nut that we need to attach this with. So yeah, everything looks good here, and we'll just go over there and get this attached to the traction loss assembly, platform assembly, and see how all that looks. All the wheels are now installed on the traction loss assembly, and I was looking at the 3D drawing. If you guys go back and look at that section, and you could see that the wheels were actually set back a little bit from the front of the frame on both the front and the rear. There's really only one place to put the actual middle wheel. But these guys, I have them 140mm from the edge over here. So it's 140mm center here. Because I just went over to the base assembly, and those plates, I just measured to the middle of that from the rear, and that was 140mm. So that led me to believe that's where it needs to be, and I'm pretty sure that's fine. So yeah, 140 there. Also on the front ones, 140mm, because they were the same on the plates over there on that assembly. So yeah, everything's the same. And the rear one, I just centered it on the whole frame. I think that was 330mm. So everything's centered up where it should be, I believe. So now, yeah, the only thing we got to do now is flip this thing over and go ahead and install it on the base. These are the landing assemblies, or feet cups, if you will, for the feet that are on the bottom of the actuators. Now, this is a flat area in here, so this is a non-captive type of assembly, so it will have some freedom of movement, the foot of the actual actuator sitting in here. And very nicely done, by the way. The powder coating on here is great. All this is done in-house at PT Actuator. I mean, they do their own milling and everything. This is a nice thick piece of aluminum in here, because you can see it's not as deep as it is when you look sideways how wide this thing is. And we have some holes in the bottom where they've actually attached it. And you can see they actually have some lateral movement here on this cup. And everything's just so well done here. The powder coating, everything is just really nice. This might be anodization. Anyway, it has the ledges inside of the holes, so it'll capture our 15mm stainless steel socket head cap bolts that we'll be using for installation. And that is an M6 on the top. And we're going to continue using our M8 T-nuts with the little spring tab on them. And again, these are M8 bolts for the M8 T-nuts. So yeah, very nicely done. All these units, just almost like jewelry. So we're going to go ahead and get this mounted onto the traction loss frame assembly, and yeah, see what that looks like. So our foot landings for the actuators are installed now. And we installed them at the very end of these profiles because that's the way it is in the 3D rendering, so that's the way I installed them. So yeah, the traction loss is finished now, except for obviously I got to put an actuator in there. And another thing about the traction loss, make sure you tighten up the set screws that are in that bearing that I showed you before. Then you got to tighten that around the pin that comes through the bearing. Just make sure it grabs the pin properly so the traction loss will work properly. So yeah, it's looking good. So here's how I'm going to install the traction loss actuator. Now I've already got the bracket for up here on the housing installed on the base assembly that we already made. And you guys, if you've been following along, know that. And I had to wait to install this, though, until I had the traction loss assembly stacked on top of that, because that will tell me where this needs to be. Now, we're going to be using another bracket on the front of this that is going to connect to our rod end. And this is what it looks like. We've got a hole here. We've got a couple on the top. And, of course, we have a big hole here that's going to be sitting right there like that. All right. Get this out where you can see it. And then we're going to attach a bolt on top of the 1400 millimeter long 4080 profile. And we have another bolt that's going to attach to the side of that too on the edge. So we'll have 3 bolts attaching this and 1 big bolt attaching to the rod end. And here is that bolt. And some washers that come with it. This is a huge M16 bolt. And you can see it has a solid shaft here on it before the threads were cut into it. And that's just going to give it added strength because instead of having threads all the way down, right? And this is a 24 millimeter size, wrench size for your top of this nut head, okay? And it comes with a washer that we're going to put on it like this. And then we have another lock washer. It's got the little split in it there. And we have another 24 millimeter nylock, as they're called, nut that has that material in there that will lock down on the threads or form to the threads. It keeps it from vibrating off. But we also have the double safety. It's just like everything in here is just kind of overdone. You know, I'm not sure you really need that locking washer, but it's there. I'm going to use it because, yeah, the way the motion's working on this. But anyway, don't forget you have bushings on this that would tend to fall out on you on this traction loss rod end, and I'm sure on the surge rod end is going to be the same deal because they're basically the same. And just make sure you get them in there before you put your bolt in, right? And when the bolt fits in, you can see that solid shank part is going to be filling in this eye, okay? So which is good. That's a nice high strength area. And of course we'll put our lock washer on this side. And then let me get this out here so you can see a little better. Watch my cables, don't want to pinch them. And we'll just put our bolt on like that. And again, these are 24 millimeter. Not something I have in my regular drawers. I had to go to the big tool drawer to get the 24 mils out. And this is a 1/2 inch drive socket I'm using on one side because I only had one 24 millimeter wrench. So be advised, you're going to need that size to do this job. So if you don't have it, maybe a friend of yours or somebody has one that big and you can use it. Right, so, and that's pretty simple, right? This goes in just like that. Now, what I'm going to have to do here before I mount it, while I have it on the bench, is pull this actuator out. Remember, we have 6 inches or 150 millimeters of travel here. So I want to bring the shaft out halfway of its travel. That way we have 75 millimeters one way, 75 millimeters the other way when we're doing the traction loss motion. So you can't just put an air like this because then we'll have 6 inches one way and nothing the other. So you have to pull it out, but I want to be precise with this. So I'll get my machinist ruler out and I'm going to measure from this nice flat lip here on the outer housing of this actuator to the piston that comes out and the nut, because the nut that goes up against here has a nice flat surface. The end of this piston is kind of rounded off, so it's not great for trying to get a measurement on. So yeah, I'm going to go with the outside. So I'm going to look straight down on this, and it looks like it's 44 millimeters. Okay, so that's 44 millimeters we already have. So I'm going to pull this out 75 millimeters. So we're looking for 75 and 44 comes out to 119 millimeters. So let's do that. I'm going to go ahead and kind of guesstimate here. Now, there's 2 ways to do this. You can just twist this out like this, or you can actually pull it. And if you pull it, you're simply moving the ball on the ball screw assembly in here, and that's causing the motor to turn as I pull it out. So I can actually do it a little quicker by pulling it out, even though it's not the easiest thing to do. And then I'll fine tune by twisting or turning it. So let's see what we got here from that pull. That's, whoa, way short. Let's keep going. All right, probably getting close now. Oh my goodness, you gotta be kidding me. That is dead on 119 mils. Gosh, that was too easy. Usually you have to fiddle, but if it wasn't, then I could just like turn this a half a turn or whatever, but we want it to be mounted. Not only that, but now I got to consider how this is going to be mounted, right? So it's going to be sitting in this orientation. So that would make it non-mountable, right? I'd have to have it one way or the other. So I'm probably going to be just short one way or another. Now, see, I knew that was too good to be true. So now that I've turned it in, I'm on 118, just over 118. Still, I'm going to go with that because it's close enough. What's a half a millimeter when we're talking about 75 each way, right? And that's going to make it so this is mounted properly because the flange has to be on this side and the other side, like this, sitting, right? So then, of course, this has to be straight up and down to attach to our bracket so it can do its job. Right. How easy is that, right? Perfect. So all we have to do is go over and get it mounted, and I'm going to do that. And when we come back, we'll take a look at how that turned out. Now I have the TL actuator mounted, and what I had to do here was put the front bracket on first. And once I had that on, it gave me a good location of where the rod end would have to be. And that led me to be able to make the final adjustment on this back bracket that holds the body. So once I had that in the right place to where the bolt would line up on the bracket that I installed, then I was able to remove the actuator again and give a final tightening on that bracket, because obviously you can't do it with the actuator in it. Then it was just remounted in, slide in motor first, and then bring the eye down, and yeah, then go ahead and just get our bolt in there. And then it was just a matter of getting the bolts into the bracket in the back here that actually holds the body. And by the way, those bolts are M6 bolts, stainless steel, and they have a 5mm head on them, and there is a lock washer that you need to add to that too to make sure it stays tight. So yeah, once all that was done, everything was good to go. We do a final test, and if you watch here, what's the cool thing about this bracket is, the body that's holding the body, is, like I said before, that bearing in there allows it to rotate through the arc when we go left or right in this traction loss. And you can see it in action here. And yeah, you can see how it's free to rotate. So it relieves the side stresses of that piston going in and out of the housing. If we had this thing static mounted and it wasn't doing that, then you can imagine the load that you're putting on the housing and the piston going back and forth. Yeah, so yeah, this is, I really like the way they did this. And again, testament to the engineering that has gone into this platform. It's just, everywhere I look, it's just very well done. Everything is heavy duty. And yeah, it's just going to make things last longer because there's going to be less wear and tear. We're back in Fusion 360 to take a look at the surge frame and its components before we start building it, so we can get an idea of where things go where. And this is going to be another 4080 profile, and we're going to have 1400mm on the sides. I believe they're 520s on the ends, and we have one in the middle here holding the surge actuator itself. And first off, let's take a look at how that is mounted. And you can see there are some brackets in here, and there's going to be 8 bolts total holding this. And you can see this is not one of those rotating bearing brackets like we have on the traction loss actuator. And of course, we don't need that because this is going to be a straight back and forth action on this actuator. There's not going to be any curving arc torsional forces on it as it goes through its stroke. So it doesn't need that. And if you also look further up, you can see the rod end bolt there that is in another bracket. And we can kind of see the bracket, but the best way to see it, I think, is just to look at it here. And that bracket is mounted to an aluminum pad that is custom cut up here to mount to our back panel on the frame itself that we're going to be using for our cockpit, our profile cockpit. And then we can see the bracket itself, and we kind of rotate it as we go down. And then you can see the bottom part there where the rod end's going through. Similar to what the traction loss actuator rod end is going through, but just a little bit different design. So that's going to secure that. And we have a crossing piece of 4080 here, as you can see that the brackets will be mounted to for support. And we have the larger 4 bolts per bracket, corner brackets that are going into the corners to support that piece, which makes sense because there's going to be some pressure there. Now we also have, let me see if I can show you guys these. See these corner brackets? I'm looking towards the rear of the frame now. These are very large corner brackets here, and I believe they're 4 bolts each side. And that's to spread the loading forces, obviously, in the corners to help support this frame be nice and strong and stiff. And of course, we have some in the front. We'll see those in a minute. So yeah, that's got the basic frame construction. Pretty simple, really. But let's look at the brackets that are going to be mounting on here for holding our actuators. You can see these are very large brackets. They have a lot of holes, pairs of holes going through here. They got we're looking at 5 of them there, I believe. And yeah, so there's a lot of holes in there. And as we get to the bottom, if you'll notice, this is mounted as low as we can get it on as far as the actuator itself where it's sitting. And that is to keep the weight as low as possible in this chassis. It's just like a race car. We want to keep the lower the weight, the better it's going to behave and perform. You don't want to get it any higher than this, I would imagine, because then it would kind of the weight would be sluggish because it's kind of mushy, if you would, because it gets so high, it gets tipsy. So first thing on the top, we're going to look at these corner brackets in here. And these corner brackets, You can see them right here. My arrow is. They are, let me get my little orbit back, little gusseted corner brackets. And they've actually welded a piece of metal into those corner brackets. Actually, let me pan this over a little bit so we can get a little better look. Yeah, that's better. Center it up a little. Go back to my orbit. Now we can see a little bit more. So there you go. Now we can see the two bolts, one on each side of that welded in gusset there. That's the start of the holding part of the bracket itself. And if we go back around, you can see underneath that we have this spacer pad here that's similar to the pad we saw over here on the surge actuator. And that's to space things out a bit. And the reason we need that space, you can see the linear bearing rail here and the bearing sitting on top of it. Then we have these carriages sitting on top of those bearings that are actually holding our cockpit. And they need room to get past this fixture right here. And that's why you see that little gusset angle at like 45 degree there. So it can freely move in between there and it won't drag on anything. And still getting a good support that's bolted directly to our profile that's forming the frame and to the bracket itself. And then the spacer obviously is doing the spacing to manage that also. But we've got some bolts on the spacers. We got two over there, and I don't know if we can see them. Yeah, there they are. So we've got 4 bolts total here, and that's 2 on each side. And then on the inside, from the inside, the other side, we're going to be, before we mount these actuators, we're going to be running 4 more bolts into those spacers. Then the final element of fixing this is another piece of 4080 profile. You can see that here. And it's not, doesn't look like, I looked all around here. I can't find any kind of angle brackets or anything that are attaching that to our frame. So it looks like it's just connected between the brackets themselves. And I think I can get this around so you guys can see it. There's a bolt there. You can see up in there. There's one of the bolts. So this has been drilled and tapped with thread so we can get some bolts in there to attach it to the bottom, very bottom 2 holes of our brackets that are going to hold the actuators. So there's, what's that, 2, 4, 6, 8 more bolts holding each one of these brackets. And of course, we'll have 8 bolts for each actuator. You can see how that's mounted there. And zoom back out here and see if I can rotate it around. You can see the 4 over there. Right. Pretty simple, really, as far as what we're going to be doing in this assembly. And I'm not going to put the linear rails on yet until it's actually sitting on, like you see here. I've actually taken the actuators and set them in their cups, and everything's sitting there. Then I'll go ahead and put those on because they're heavy and no sense in adding weight when you're going to have to lift it anyway. And on the rear, we can also see the same exact setup, nothing different there as far as that profile spanning on the bottom, and then of course our spacers and the brackets on top of that. So yeah, let's go build it. Here are the brackets we're going to be using to make the base surge frame, and that's just basically going to be the rectangular box with one 80-20 going across. And these are these big gusseted corner brackets that we saw in the 3D rendering, if you guys watched that. Nice units, aluminum, and yeah, should be very sturdy. These babies into the corners with 8 bolts on each one, 4 on each side. So, and then we have these that we're using for the surge actuator 4080 profile connection to the rest of the frame. And you've seen these before. We have 2 bolts on each side and the big gusset on that side. Right, so really not much to see here that we haven't already seen, but I just want to show you guys the brackets I'm going to be using to making that. So what I'm going to do is go over there and go ahead and get it fastened together and take a look at what that looks like. I wanted to give you guys a quick look at the brackets that we're going to be using to attach the surge actuator to that 4080 piece that's crossing in between the surge actuator frame, or the surge frame basically. So it's got larger holes on one side, and these go against the 4080 profiles, and we have a smaller holes on the other side. And these are for attaching to the side of our actuator's housing. So you got 2 different size holes. And the reason I'm showing you this is because there is a particular bolt you're going to need to use here, and that is these button head. M8 button head. I believe that's a 5mm head on that as far as the hex size. And the reason is, once we put this in here, and we're going to be using these spring leaf and roll-in nuts. Once we have this in here like this, you can see the button head won't be in the way of this M6 bolt that we're going to need to use to go into the side the housings. If I had a socket cap head in here, or even a bolt on top of those T-nut studs, it wouldn't fit. But it will fit with that button head in there, you can see like that. So we can still get it in there and still get a wrench on it and tighten it up properly. So that's just one of those little caveats and little gotchas that, you know, you don't want to go over there and put the wrong bolt in there and then go, oh gosh, I can't put it in. I got to take everything back off. So I'm trying to save you a little trouble here. All right, so that's it. Pretty simple otherwise. And yeah, we'll just go ahead and get these brackets mounted. All right, guys, we have the surge frame assembled, at least the base frame. And of course, we're going to be putting some other things on this. So I just want to show you what it looked like once it was assembled. Of course, I'm not sure where the center bar for this 4080 is going to be located just yet because I haven't put the actuator in there. And I need to put the actuator in there with the bracket attached to the rod end to get a measurement on how far it can go. So I'll extend that. Once I bolt it in, I'll extend it all the way out 6 inches or 150 millimeters to where it stops with the bracket on the end of it. So I know that I'm not going to hit this back rail here. That's a crossing rail. And yeah, that's just the way you have to do it. Now remember, we can position our cockpits just about anywhere we want to in the linear bearings cradles, right? Those carriers. So we can put that anywhere we want to even things out. But we just don't want to be ramming, obviously, the actuator's rod end or the bracket into the back of that when it's moving back and forth. Another thing here, important consideration, while you're building this, make sure, because we're going to have a linear rail system on here, we need to be as perfectly parallel as we can get on these profiles, because you don't want to be out and, you know, have a gap at the front and like a couple millimeters gap at the back, because that's not going to be perfectly parallel and the bearings just won't track smoothly like they're supposed to. Now I was able to get this dialed in perfectly. It's at, I believe I'm at 542 millimeters or 21 5/8 of an inch, dead on center, all the way across here. And I'll just measure at the end down there and measure down here at this end, and then that'll tell you. Now, if you're out like a 1/2 millimeter or something, that's no big deal, because remember, the carriers are going to be not moving that far. We only have 6 inches of total travel. So it's not going to matter, you know, if you're out a 1/2 millimeter or a millimeter or something, it probably won't hurt you. But you do your best when you're tightening these brackets up, these corner brackets. If you rotate the bolts from side to side, you should be able to pull this profile in completely square. And that's because the brackets are perfectly square. And that's what's great about profile. You usually end up, if you tighten it in the right sequence, you end up with something that's perfectly square. Right, so yeah, I like the results so far on this. It's looking good. And yeah, we'll just move on to the next segment. The next parts that I'm going to attach to our surge frame is going to be this bracket that's going to hold the mega monster actuators. And you can see it has a lot of holes in the back, just like in the 3D drawing when you saw that. And we have 4 holes on each side. It's actually going to attach to our actuator. So if you watch the 3D picture, you know we've got 3 different things we're going to be putting on this. And I got a little model here of 4080 series. This is not the 4080 series we're using in this build, but just an extra piece that I had. Right, so there are 4 of these. You guys see those in the picture? And these are very nicely done aluminum spacers, and spacers that obviously are also performing the attachment role. Now we have 6 holes here, and then we have 4 in the middle there. Now the 4 in the middle, you can see, are tapped. All right, so they're tapped for M8 threads. And these other 6, you can see, are counterboard. See a little ledge down there for attaching to this profile. And we're going to use these 20 millimeter long M8 stainless steel socket head cap bolts that have a 6 millimeter hex head on it. And that's simply going to fit down into this like so. Right? So we got a lot hanging down here, and that'll catch the nut on the other side that's going to be inside of our channel. Right. Once that's installed, then we can take this. Let me go ahead and just get rid of this bolt. Once it's installed on the profile, it'll be sitting like this. I'll turn it sideways so you can get a better idea. So this is the spacer function that it's performing, right? So it's spacing it out far enough that we won't have to worry about our linear bearings ramming into it when our chassis is rolling back and forth. And I want to get my little micrometer here and show you guys just how thick these are. They're really thick. And they're substantial in hand, and they're aluminum. They still feel pretty heavy. And they're coming in at 20 mil. So yeah, pretty substantial pieces here. So we have this stacked up now to this. Then we're going to come in with this gusseted bracket. Now this is their own in-house made bracket, and you can see the welds there, the weld beads there. It looks to be nicely done. And this is all steel. And it's about 3 or 4 mil thick. 4 mil. Okay, 3.9. So that's 4 mil thick. And if you notice, we have one flange that's longer than the other side. The other was kind of short. And that's again, so let me turn this sideways. Now that we have our spacer on there, this is going to sit in the top channel on the long way. This long stretched out part is going to sit in the channel with some M8 bolts and some nuts, right? T-nuts. And you can see when that happens that we're spaced perfectly with the plane that is on the front of the spacer. Right. So we turn it this way. And this is how it's going to mount to our actuator mount. And it's going to be with these holes here, over here. We've got 3 holes that we're going to be using here, or actually 6 holes. Or we've got this row is going to be used, this row, and this row. So if I turn this sideways again and bring this in here, these holes will line up, right? So we've got 2 rows down here and up here, but there's another catch. There's another piece coming in here. I'm going to put that down so you guys can see how that's going to work. So I'm going to pick this up. Hopefully it won't slide all over the place, and it did. But I kind of knew it was going to do that. Oh, by the way, these are the profiles that have the, you guys see, let's get you a close-up of it. See how these are actually tapped? You can see the threads in there. So those are M8 taps, okay? And this is going to sit on the bottom of the rig, the total bottom, right? There's really nothing attaching this to the rig except where it's going to attach to this bottom set of holes here. So it'll be sitting here like that, and we'll bolt it on, right? So it's kind of taking both of the brackets from either side and bringing them together and supporting them this way, right? So they can't go this way or they can't go that way, and helping the support that these guys are doing. So we're going to have 6 bolts here. Then we're going to have 4 bolts holding the bracket part. Then we've got 4 more bolts for this. And then we got 4 more bolts for this to attach it to the bottom of the bracket. So we're going to be using the bracket holes here, 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 and here. So that's a total of 8 bolt holes that we're going to be occupying, holding this bracket. And this is a massive bracket. It's 360 millimeters long. It's all steel. The same steel, I believe it's on the brackets. It might be a little thinner. I think this is thinner. Let's see what we get. Let's see. Yeah, 3 mil. Okay. A little over. So this is 3 mil. And of course, this has been stamped or it's been put on a machine where you can bend this, a brake, if you will. And yeah, so, but it feels very substantial, very tough, very stiff. I think that this is going to be fine for holding the actuators as we run our motion system through its paces. So yeah, that's about it. That's what we're going to be doing. And only thing you got to remember is we need socket cap heads for these guys, and we're going to need 24 of them. So there's 24 over there in the kit. And then when we're actually bolting this together and we're putting this bracket onto here, we can also use a socket head cap, because this is going to, how this mounts, see how these holes, how much room I've got to the edge here? So this actuator is going to be sitting out a little bit. So it makes room for any kind of bolts or nuts that are sticking out in here, right? And we're going to mount this at the lowest possible position on the frame, because again, I'm trying to keep my center of gravity very, very low, or just all the weight as much possible, as low as possible in chassis, just as you would in a real race car. So let's go ahead and get this bolted on and see what it looks like. The actuator brackets are now attached, and yeah, I'm actually calling this an assembly because there's so many things that we did to get these things attached over here. And you can see we have 8 M8 bolts attaching that to the spacer. And we'll come around this way. And you can see on top of the spacer, which has 6 bolts in it, attaching it to the 4080 frame, we have the gusseted corner bracket, and it has 2 bolts there And I put 2 button bolts in there that I had just because they're low profile and I like the way they look. And we also have that bottom 4080 piece. You can see that there. And that's attached down low here to those last 2 holes. You can see the front of the holes there. And it runs the length over to the other side. And yeah, that's a lot of bolts to tighten. It's kind of tedious because there's just so many bolts to tighten down. And not only that, we just finished building the frame, which, as you know, we have a lot of bolts in this too. I mean, we got 8 bolts in each one of these corner brackets. So, and then we got the same thing going over here with this middle bracket. Now on the back here, on the rear of the 1400 millimeter profiles, you don't see a bracket. The corner bracket's not here. And that's because I still have to install the linear rails on both of these. And I'm not ready to do that yet, so I just left them off. And what I'm going to do is just slide the rails using their T-nuts, obviously, in the channels all the way up. And they'll be centrally positioned based on their length in this chassis. So yeah, that's about it. I think we're done now. As far as getting that done, all I have to do is start attaching actuators. So we might take a look at that next. So let's take a look at the PT actuators that we're going to be using in this system. First, we'll look at the yaw and traction loss models. And these are exactly the same for traction loss and the surge elements that we have on this system. And this is 250 millimeters per second. Let's go over some specs. And that's at 80 kilograms. And it is 150 millimeters of travel, or 6 inches of travel down here. So that's pretty good specs. In fact, it's the same specs almost, except for low capacity, as the big guy over here. So this is made in PT Actuators factory. They control all the, from the motor flange over here all the way down. This is all their manufacturing. We have a 58 millimeter outside housing here that our shaft will go in and out of. And the shaft itself, it comes in at 35 millimeters. So a pretty substantial piece here. It really feels good in hand. 5 kilos or 11 pounds. So yeah, this is something that instills, again, like most of the stuff here, confidence in how these actuators are going to be able to function. And this one, I'm going to show you the label here. It says it's a baby monster for simulator. And you can see it actually says the axis down here is for surge. The other one, like this, will say traction loss, or TL. So you know which one is which. And there's a look at the motor. There's really not much to see there on the motor labels. At 3,000 RPM. And they're all 3,000 RPM. So that's max, even though they're not going to run at the max. I think they're really going to run around 28 to 2,900 once we're actually using them. But we'll check that out when we get to that part. Right. Anything else we want to talk about here? These cables. All the cables are shielded for the power lead. So you got 4 pins there. So this thing is actually shielded for the power lead. And I'm going to show you a little more detail over here on this guy. And also we have this massive steel rod end here. And that's how we're going to connect to our traction loss and our surge elements. Very cool. And you can actually pull this out a little bit because it's a small one. And because of the ball screw that's in here. And speaking of ball screws, they use a well-known or industry-recognized ball screw from TBI. And that's, like I said, a lot of people use that. They use a model, the SFS model. I'll show you a little picture of it there. So yeah, something that a lot of people use when they go for the quality ball screws. You can either screw this in, or you can screw it out, or you can just push it in. When I'm pushing it in, I'm actually, unless there's a clutch in here, I think I'm actually turning the electric motor shaft, but there might be a clutch mechanism in there, so I don't do that. Right, let's talk about the big boy. We'll put the baby monster away and talk about this guy's kind of heavy. And this is just one massive, beefy actuator. I've never had anything this big in the SRG as far as, actuators. This thing is just so big. And it's not big this way, though. It's not very tall. In fact, it has 150 millimeters of travel in it. It's not even close to as tall as some of the other ones I have that have 150 millimeters. So, yeah, I like that part of it. It's more compact, but it's also, very beefy looking. Again, they make all this stuff in-house. They're machining as far as these housings here that hold the ball screw mechanisms, and of course the outer housing that holds the internal shaft that goes in and out. So this comes in at like 70 millimeters for this body as far as the diameter of it. And the piston or the shaft going in and out is 50 millimeters. So it's just so big. And the specs on this are just like the one over here, believe it or not. It's 250 millimeters per second and 150 millimeters of travel, or 6 inches. And it's 150 kilos for load. So 150 kilos, that's like 330 pounds. If you have 4 of these, that's 600 kilos, which is like 1,322 pounds, somewhere in that area. So I think that's plenty of weight capacity for just about anything that you would be throwing at this in a simulator, especially a car simulator or a flight simulator or something like that. Yeah, I don't think you could ever go. I mean, just how much weight can you put on these things? Even with the heaviest stuff that I have, my pedals and my wheelbases and stuff, I never get close to those kind of weights. Right. So let me give you a close look at this. Let me pick it up here. Yeah, show you the front here. And you can see this one they call the Mega Monster instead of the Baby Monster. And you can see we also have the Axis B over here. And of course we have Axis A, B, C, and D for these big guys. And that's so that you put these actuators, if you're following the charts right, or the directions right, in the right positions, okay? And that it makes it just make it easier to troubleshoot and to dial in the sim tools and things like that if we do that. And the motor label is over here. And again, not much to see there on the motor. So I'm not sure who's making these motors for them, but they probably order a lot of them from whoever the manufacturer is and just have a regular sticker put on there. So we don't know who makes them. Now, back to the shielded cable. Now, you guys know that I'm always concerned about EMI, RFI interference, which is a real thing when it comes to having all these motors and electronic boards and circuits running on our simulators because there's so much stuff going on. And I like it when the companies actually put shielding on their cables. And this one is shielded on the power cable. And I'm going to take this cable off here, or loose anyway, not off, so you guys can see this, how they're doing this. There is a shield, metal shield inside of this cable, and they attach a ground wire. Let's see if I can get this off of here without hurting anything. There we go. Get this a little bit closer. All right, so there's our 4-pin power lead. I'm going to turn this around. You're probably not going to see it too well. I hope we got enough light here you can see. Now, there is the yellow-green ground wire. See that there? That's what that is. But if you see next to it, there's also some copper wire coming out next to it. And that copper wire is attached to the shielding in this cable. And it's also attached to the other side in here to a ground. All right. So we've got shielding from here to here. Right. And then when we connect our other cables, we have shielding in that too. You can see the same ground wire on the other side of this connection if you take the cable loose. And that travels the whole length of the cable. So yeah, and then it comes out the other end of the cable, and you'll see that when I'm attaching these actuators to the servo drives, and you'll see that when I'm attaching that. So yeah, nice to see that they've gone the extra step here and put shielding in for the power cables. Anything that helps mitigate EMI, RFI interference, I am a total fan of, because it only takes one time when you have problems with something like that. Trying to chase that down, an issue like that, it's like really not easy. It can be quite frustrating, actually. So yeah, I'm really pleased that they've gone this route with this. I think all manufacturers of actuators are going to be using simulations, or simulators rather, should have shielding on their cables. And when they do have them, it just shows that they are aware of the issues and they're trying to mitigate them. And yeah, I really like this. Right, so what else can we talk about? I think that's it. What I'm going to do next is we'll just get to the next segment, and I'll show you somewhere in this segment here. I'm sure I'll have a segment that shows you how I'm mounting these over onto our chassis. Now I have the 4 main actuators attached to each corner, and there was 4 bolts on each side of this, and those are M8, 13 millimeter long M8s, and of course it is a 6 millimeter hex. Now I'm also using a washer and a lock washer on top of that, and it comes in the kit. I'm going to show you over here on my table here. There it is. And this is the assembly, and it's only a 13 millimeter long bolt because the holes that are in the actuators themselves aren't very deep, right? So yeah, you put the washer on, and then you're going to have a lock washer also to help hold this, because there's going to be some vibrations, obviously, with a motion system in this. So you want to make sure that we have something in there to keep it locked in. So, and usually these lock washers do a very good job of that. Right, any other things we need to talk about here? I really like the way this sits low toward on the chassis here. See how low this actuator foot is sitting? It's really, I like this because it's going to keep the center of gravity very low in the system over here where the base and the traction loss platform are. And also, when you line these up, actually I did this before I even put the brackets on, I measured the centers on these spacers to make sure that I was exactly at the same spot as the centers over here on these cup landings, right? But I also leave the cup landings just a little loose in case I have to tap them one way or another. But I'm pretty sure I'm dead on the measurement. So it's easy enough. You just get the center off the cup base from the back of this profile here, right? And I believe it was like 65 millimeters, if I can remember right. And then I did the same thing with the spacer bracket over here, because the center of that is 65 millimeters from the back of this 1400 millimeter. So if you do the math right and you just measure it out, you shouldn't have any problems here for this stuff. I should be able to pick this up and drop it right on this without any issues whatsoever because of the measuring that I did, right? Only problem is I can't lift this thing up by myself and set it over there. So now I got to call up my friends and see who's available, see if I can get somebody to come over here and help me lift this thing. Yeah, one guy on each end is definitely the way to do this. And then we'll take it over there and set it on the base. As you can see, we have the surge frame sitting on top of our traction loss frame now. And the actuator feet are in the cups. And it went in very nicely. The only issue I had was the cups lateral movement. In other words, they're a little bit too close to the inside, and I had to change that, or the outside rather, on this side that we're looking at. So it's not a hard thing to do. I just put a block of wood under this and to where I could clear the bottom of the feet. And I'll show you a shot here of the bottom of the cups. There's 4 bolts in there. That's a 5 millimeter hex bolt, and you loosen those up and you can slide it laterally. And I just made a 2-3 millimeter adjustment on that. And then, yeah, easy enough to get them back on, and there we go. So now we have the result we're looking for, and that is a non-binding setup. Remember, this is a non-captive cup, so you do want a little movement in there when you move the actual rig around, or the surge. So I'm going to show you that right here, if I can keep from shaking too much while I'm doing it. So see how this is moving around? It's got some leeway, okay, so it's not binding anywhere. So if I can move it like that, then we've accomplished what we've set out to do, right? So there it is. Now all we have to do is get on with the rest of the build. Now I have my surge actuator mocked up, and I went ahead and installed the bracket assembly to a piece of 4080 so that it would be exact same size of what I'm going to be connecting to, which actually is going to be a 4160, but I'm using 2 channels of it, so it's the same thing. So I can mock this up properly to see exactly where this actuator is going to end up. And if I get down here and look in my brackets, on the side of these brackets, I can see that my holes are lined up, right? And that's the distance I want right there, because I have the actuator completely extended to its stop, mechanical stop, so that it can't go any further, right? And not only that, but when I raise it up, it's kind of leaning down right now, but when I raise it up to where it's going to be flat against this piece, then my holes are still lined up. Make sure, yep. But it actually pulls that assembly back a little bit. All right, so at this configuration, or this where I'm setting right now, I can get in here and look at this and see that I have about 10 millimeters of space between my bracket that's on the end of the rod end and that back 4080 piece. And that's where I want to be, because obviously it would not be good if this went out in its full travel length and whacked up against your 4080. That would be a disaster. So that's why that I took the time to assemble all this and mock it up properly, so I know exactly where it is and there's no guessing to it. So yeah, I think we're going to have a good result here. And of course, I also have to be centered, or I want to be centered, right here across between these two 4080 pieces, these 1400 millimeter pieces. I want to make sure I'm dead center there, and I will get that. I don't think I'm dead center at this moment, but I'm going to bring these brackets in. You can see they're loose, and then I'll take my measurements and make sure I'm center on that. And yeah, then we should be done with as far as mounting the actuator. So I have my surge actuator mounted, and everything's secured tightly, and everything's lined up like it should be. There's a couple of things that you want to consider here when you're mounting this. First, you want to make sure that your 4080 piece here that crosses in between these and it holds the bracket assembly is perpendicular to these 1400 millimeter long side pieces. And you should be able to get that pretty easy just by rotating the bolts that you tighten up from here to here, then here to here. It should pull it in square to this already square profile. And that should square it up for you pretty nicely. But you can check it with a square if you want to. Now, also, you want to make sure this is dead center in between these two profiles, the long pieces here. And I did that, just measure across that, divide it in half, and that'll give you where you need to be. And another thing you got to consider is the level. You want to make sure this is level with these pieces here. And that's, again, not too hard to achieve because this is a flat level piece here anyway. So last thing I had to figure out was how square this was, or perpendicular this piston's coming out is to this back piece here. You want it perfectly perpendicular. You don't want it sitting off at an angle and pushing and pulling, because remember, this thing doesn't rotate or have a bearing in it like our traction loss piece does down there. So yeah, you don't want that to happen. So you need to take a square, and that's how I did it. It's just a little machinist square, and you want to take it from the back here, back edge of our profile, which is a square, and just kind of put it up against it, and then look straight down on the motor case here, and I can just push this in very slowly, and when I can't see any more, I'm looking for the gap to disappear, and if it disappears all at once as I'm pushing it this way or sliding it that way, then I know I'm square. Back here, which should put me perpendicular over here, which it does. In fact, I can come down here and get another square measurement and see that everything's looking very good, right? So that's important. You don't want to have this off angle. So yeah, it's a very solid piece here as far as the way we secure this. We've got 16 bolts on the bracket. We've got 16 bolts on the 4 corner brackets that we're using here. So that, and once everything's torqued down, it's a very solid feeling piece, no doubt, right? One issue that I did have is the socket head cap bolt heads here were too big to even make it past these button heads. And I'll show you a picture of that where it's trying to get by. Even though it looks like I could pick up the bolt a little bit and still get it past it, it won't. It still hit the top here. So, and if I went the other way and I put the socket head cap in first and then tried to go in with this button head, I couldn't get in that way either. So what I ended up doing was sourcing, and I've got a bunch of parts, I have spare parts in my bin, and I was able to get some M6 bolts here that had button heads on them, and that was how I ended up doing this to fix it. And yeah, you know, there's the same size as these. These are 16 millimeters long, M6, and those are 16 mil. You want to be able to use your lock washers in here, and I even tried this button head without a lock washer, and it was still too high and it interfered with it. So you don't want to not use lock washers here because there's a lot of torque and pressure on this piece, and you want to make sure that nothing comes loose on you during use, obviously. PT Actuator told me they'll be fixing this by drilling the holes further away on that bracket. Now we're going to look at the linear bearing system that's going to be put on this cockpit, or rather on this system, and our cockpit will fit on top of this. And this is going to allow us to slide the cockpit back and forth with our surge actuator that we've already seen. And this is a very heavy, substantial piece of steel here, very stiff, and it needs to be, because obviously we don't want this thing twisting or warping under the pressure of having the bearing sliding across it, which usually is pretty smooth anyway. But we have 20 holes in this rail, all right? So we're going to have to put a bolt in each one of these. And before I get to showing you how I'm going to do this, I'm just wiping some of the oil and grease off of this, because when they come out of the bag, they come packed in a plastic bag. There's a lot of oil and grease on it for transport, which is good because you don't want any rust getting on it. Anyway, so before we get to the screws or how we're going to mount it, I probably should show you the bearing system. And this is the bearings. Actually, the bearing carrier, if you were carriage, some people call it. Doesn't really matter. The bearings are inside each side of this channel. Oops. In fact, I'll pull it out and try to give you guys a close look. This little keeper here is in there to keep the bearings from falling out on you. If they get jarred in shipment, they could fall out, but I'm going to be very careful and not jar them. All right, so you can see the row of bearings in there, and we have another opposing row on the other side. Very simple. And I usually put these in like this if I'm going to put it on a linear rail, just because it's upside down, and yeah, you don't want to take the risk of anything falling out. And you see it has these grooves here that are exact match for this pattern here on this rail. It's kind of a modified hourglass pattern, if you will. All right, so this is going to obviously fit on top of that. And so when I put them on, I usually leave that plastic piece in, and as I'm pushing it onto the rail, the plastic piece will come out the back. And I just kind of hold it there as I'm bringing this in. That way it makes sure that the bearings won't fall out. Because as soon as a bearing falls out, you can put them back in, but it's kind of a nuisance. So, avoid it if you can, right? Let me get my other rag here. Again, everything is very oily here, which is a good thing. You want it to be slick. And now we have it mounted, and of course it's just going to roll on that rail like that. Okay, so once we have this installed, then of course we're going to mount our cockpit on it, but we need a bracket to hold our cockpit. This obviously won't do. Now there are 4 screws on top of this, or holes with threads in them, actually, not screws, screw holes. And we're going to put this bracket on top of it like this. Pretty simple, and then you put your 4 screws in. Only thing is, if you look here, this bracket has, obviously we have 4 holes here. We have the recessed holes here for flathead screws, the beveled holes. And over here we have these slotted holes so that we can adjust the screw, the bolt, the M8's going in here up and down so it can match the profile without any problems. And we have this, what looks like to be some kind of a Delrin or something on here that's going to be sitting up against the cockpit itself. And it's bolted on the back with these 2 hex bolts or screws. All right. But if you can see, this hole here is, some of it is underneath the ledge that this pad is creating. All right. So when you actually put it together, you can see that that screw is actually underneath there a bit. And because of that, there's a little technique that you need to use to make it easier, make your life a lot easier when you put this on. And that's simply put the 2 screws here first, but just get them started so that they don't come out. And then you can put the other 2 in. Now, if I laid this flat and tried to put those other 2 in close here, they won't go in, because before they can get straight enough to go into the threads and engage those threads, they're going to hit this piece. So it'll never happen. So what you do is, when you have these 2 screws loose in here, you can just tilt it up a little bit. And that gives you enough clearance underneath to be able to drop the screws into those holes. And then you can lay it down flat and go ahead and start screwing them in. As you lay it down flat, you screw them in and it just goes right down. Just a little trick there to make your life a little easier when you're trying to build these things. Now, when they are built, you don't have to do this, but I do this because for future maintenance. They all come with holes in them. I'll show you the hole here. They're not holes, but actually they have screws in them like this one here does, right? So they have these screws in there because you don't want a bunch of dust and garbage getting in there if you don't have to. So I've taken one out to show you that that's what the screw hole looks like. And it's some green plastic in there, threaded, some kind of a tough plastic. It might even be Durlin itself, I don't know. But on the other side, I've got a grease fitting, and it comes with the bearing in the kit. Every one of these bearing sliders comes with that grease fitting. And I have it sitting so that the cockpit will be sitting, let's say it's sitting like this, and the cockpit's sitting in here up against that 40-160 piece that I have. And this way I can come from the outside on each side of my cockpit and hit these with the grease gun. No problem. Okay? So that's just so you can maintain it. And of course, grease on a rail like this is something that you always obviously want to be able to put on it, and greasing the bearings internally that way. Now, there is a little bit, it can be a little finicky, because sometimes if you take this fitting and you screw it in, when it gets tight, it's pointing in the wrong direction. It's pointing up, which would hit the cockpit, pointing down, which would hit the rail, not good. Or it's pointing over here, which is from the inside, which you could still do that, but I still wanted to do it from the outside. So an old trick to fix that is to put start stacking some spacers in there. See those? I've actually got 2 washers in here. Hope you can see that. And it took that much spacers, or that many spacers, not that much, or that much space, to get it to land where I could turn it with the wrench. And these are 8mm little hexes around these things. Turn it to get it nice and tight, and it's sticking out the right direction. And I went and did every one of them that way. Now, sometimes if it doesn't work on this hole, that's why I have, another reason why I have both screws out, is you can come under this hole and try it, and it might land where you want it to be, to land. And that's happened too. But yeah, that's just something that, when you're doing this kind of a build, there's something to be aware of if you want to be able to lube your bearings and maintain them. Again, you don't want the bearings running dry, or not only that, but if the bearings get dirty, you can actually inject the grease in there and it will force the dirt out with the old grease. So yeah, it's a great way to maintain your system. Now, to mount this system, and I'm going to pull this bearing back off, and I'm going to do the same thing I did when I put it on, but in reverse. I'm going to get that little piece in here in the groove. There we go. And slide it back onto the plastic as I'm sliding it out, just so the bearings don't fall out. Then I'm going to flip it around and show you what those bearings look like. All right, there they go. See, there's a row of bearings in there. Nice and shiny. And of course, on the other side, there's another row of bearings in here. And that's what rides on the very edge of this piece of steel. It makes everything work so well. Okay? In fact, this got a little bit of a groove there that the balls actually fit in. Oh, hell, well, you can see that. But it's right, there's a little groove right in here. Yeah, there you go. I think you can see it there. And that's where the balls are riding. Okay, so let's go ahead and put this back in before I drop it and the bearings go everywhere. Okay. We're going to attach it, 20 holes here. So we're going to need to bolt this down, obviously. Now, this is the bolt solution that was sent from PT Actuator, even though they're going to change that now, because I've talked to them a little bit about it. And even though this will work, this will go in here like this. You unscrew, drop it in, and then we'll screw it on the bottom. Okay, so this will slide into a piece of 40 series, and that's what this is. And I can just slide that in there. Or if I keep them straight, I can just drop it in just like we've been watching through this whole build. And then tighten it up, and it will tighten down on this, all right? And eventually as it comes up, let me turn this a little bit so you guys might be able to see this. Okay, I guess I'm gonna have to tighten this up. I thought I could do it without doing this, but I'll go ahead and just snug it up and show you what I'm talking about. So we'll go ahead and tighten this up, and as I tighten that up, this is turning inside of here. You guys can see that. So it's going to turn once it gets to the top. There it goes, it's turning. Oop, and then it's going to tighten down. Okay, and that'll work. But it doesn't engage enough of the channel. I mean, I've done some linear bearing builds before, and there's actually what I think is a better way to do it. And that is using these T-nuts. See how this T-nut has more sticking up from the bottom here? So that tab will actually engage this channel right in here. So you got more tab engaging the channel because it's much longer than what we have on this bolt or this T-nut assembly. Let's go ahead and take that back out and do the comparison. So what we're trying to do here is get as much surface area engaged with these channels on these profiles so that, get that bolt out, so that any linear or rather lateral move or pressure on this, it stays where it's supposed to stay, right? And this is going to give it more grip. So you can see how much surface area we have on this guy, all right, compared to the surface area we have on this one. This is going to be engaging that channel. All right, so they both engage the channel, but you can see where this would be more advantageous because we got more of a load bearing surface on both sides, right? And it works the same way. We still have a 20 millimeter bolt, and we just sit it in here like this. I'm just using the end. In the end, we won't be using, actually on these ends rather, on the holes, we're not going to be using these short ones. We're going to be using longer ones, and I'll show you what I'm going to do with that and why I'm doing that. All right, so we can spin this up a little bit. And then we'll put this in the channel. And we will put this in the channel. There it goes. All right, so now when I tighten this one down, and it's kind of a self-aligning thing too. So when it does, and you don't want to tighten up too fast because you don't want it turning around before it makes it into the channel, the top part. And then once you tighten that down, so now I've got a lot more surface area in here grabbing the top of that channel than with this guy here. It's just not even a comparison really, especially when you're talking about 20 of these. Now, I could still turn it a little bit if I really do it hard, but because there's that much more area gripping this channel, it's much harder to turn this than it was this guy with just one of these in here. Now, of course, when we have 20 of these all the way along this rail and we tighten them all down, torque them down, this rail is not going anywhere. I guarantee it. Now, one more thing I want to show you before we get over there and put this on. Let's go ahead and take this guy out. Okay, is on the ends of your rails, and I don't think it shows it in the drawing, we want some kind of a stop mechanism here on this one and the one way down here. just in case we go too far somehow, some way, it doesn't slide off the end, all right, or bump into one of the brackets on the end. And how we do that is, this is how I do it. It'd be better if I had a spacer that would fit down in this hole, but I couldn't find anything that would work that well. And so I'm just going to use a couple of stainless steel washers. And this is a 25 millimeter long M6 bolt, all right? So we're going a little bit longer than the ones we're going to be using going everywhere else on the ends. And the reason is you need it longer because this bolt's not going all the way down. It's going to sit on the top like that, right? And then, of course, we'll use the same T-nut. And once this is tightened down on each end, then you can, obviously, when this slides against that, it's going to hit the bolt and not be able to go anywhere. Hit that socket cap head there. So we want to do that on this end and this end. Of course, the rest of them will be these 20 millimeter units that are going to sit down flush, obviously, so we can roll our bearing across there. All right, I think that covers it, what we're going to do, and I'll probably show you guys some video of me with one of these with all the T-nuts in here and kind of feeding it onto the channel and sliding it in as it goes all the way to the other end. I'm going to start installing the rail now, and what I usually do is just grab the T-nut on the bottom there and make sure it's lined straight with the channel that I'm going to feed it into. And if you'll notice, there are a little bit of the screw protruding from these T-nuts because I've measured the distance I need. So I kind of preset them to the depth I want. Because as I'm feeding them, I don't want them hanging way down low, because when I tighten them up, there is a chance that it could twist in the channel before it comes up and grips or engages in our slot on the top. So if you space them properly, they won't be able to do that. So I'm just going to kind of get this one started. And you're just kind of feeding things in here. It's just one by one. I'm straightening up, obviously, these T-nuts as I'm feeding them in. And yeah, they're all engaging the channel, so they're not going to have a chance of slipping around or flipping around as I'm tightening them. And I'm lifting on the back of this rail, taking the pressure off of it as I'm feeding it in, which makes it a lot easier to do. Yeah, it's pretty simple stuff, as you guys can see. Just keep feeding it along. One by one. There's 20 of these guys. Well, actually there's only 19 because I've left the rear one out so I can get my carriage bearing assemblies on here. There we go. And I'm getting the last one here. And we'll see how that looks. Last one. Get my last one. There it goes. Always the last one. So yeah, now we can slide this in here. And I can see where it's going to come as far as the back end down here. It looks clear. Up there, we're going to be clear of the bracket, so it's going to fit right in between the brackets like we want to. So now, I'm going to kind of push this up against the bracket down there and start installing these bearings. But you know what? I'll tell you what. Let me pull this back so you can get a better look at it, how this is going on. And you don't have to leave these plastic pieces in the bearings. Remember I showed you those? They kind of keep the bearings while they're being transported clean and clear. In other words, they don't get out and run around the box on you. And it can be a little fiddly to get these started. Just kind of wiggle it back and forth to get it started at first. And then sometimes you got to put a little pressure on it to get it going. Go ahead and push it all the way on. There we go. Just like that. So now it's just going to slide all the way down the rail. Like so. I'm just going to get that out of the way so I can get in here and get the other ones on. And it's going to be the same thing. Just pull a little plastic piece out and then feed it on. And again, you notice my grease fittings are all pointing to the outside. See how easy this is? When you have it all set up and ready to go. So we'll get 2 more of these on like that. These are going on pretty good. Nice and smooth. Nothing like a linear bearing on a linear rail system. If you've never had one of these in hand and messing with them, they really are a pleasure to use. There we go. Tight is good. So now we have 4 of them on here. All right. Now I can take the whole rail. Let me get my T-nut in here. There we go. And slide it in, but not all the way in, because now I've got to get one more in. That's the T-nut and the longer bolt that's going to be the stop on this end. We already got the stop on the other end, so I'm going to go ahead and drop that in there and go ahead and tighten that down. And then it should be get it to where it's going to engage. I'm kind of looking down here underneath. There we go. So now it's in. Now I can push it in there, get it where I think it needs to be. And then I'm going to leave it as it sits right now, because I'm going to get the other one done. It's not done yet. Get the other one done and get the bearings on that one. And then I'm going to start measuring. And as I'm tightening, I'm going to make sure that if I have any movement at all, I want to make sure I stay perpendicular, or rather parallel, all the way down on these two rails. It's very important that you do that. That way the chassis that we're sitting in here will be able to slide real easy. So yeah, we'll get to that part next. So now the bearing rails and bearing carriers are all installed. Everything is torqued down nice and tight, like it should be. And yeah, this is really working out quite well, I think. And you can see we have the other ones installed over there. And I'm not sure the spacing on these carriers yet. Depends on how the profiles land on this. And we come around the back here, and I have reinstalled the brackets that are holding the actuator bracket on the back. Remember, we can't have those in the channel when we slide those linear rails in. Obviously, they won't go past them. We've got our stops installed on the back. You can see the cap head sticking up. So there's no way the bearings can go over those. And we measured for parallel on the back. It was ended up to be 21¼ inches after I made my minor adjustments, because you do have some room for minor adjustments on these rails before you do the final tighten. So that's, you just kind of work it back and forth till you get it right. And everything looks good. I actually measured up here and it was the same thing, 21¼ And I also measured between our carriers here, and they are right at 580 millimeters, which for the P1X cockpit that I am mounting, that's what it has to be. And they are all right on it, so confidence is high that when I start building the P1X cockpit on top of this, that everything's just going to fit quite well with no dramas. Right, so now we can get on with the next segment. All right, guys, so we have our P1X cockpit attached, sitting in the bearing carriers. And yes, so now all we have to do is attach our surge actuator. And there's a two-piece bracket assembly. This, you guys probably already saw this in a closer look. We have this bracket that actually has the big hole that will attach down here to the rod end. And we do have our bushings in, don't forget those, because they tend to fall out when you're unpacking things and once you take that zip tie off of here. So make sure that's in there, obviously. And we've already have the CNC aluminum piece already mounted here loosely, so I can make some fine-tuning adjustments. It's mounted in the bottom and next to bottom channel in here, not on the higher ones. And again, if you have a P1X, then this is a 40 by 160 profile back here. The whole piece in here, the whole bottom chassis is made of that. Now, this will also work if you have a 40 by 80 cockpit. So it doesn't have to be a 160 because we're just using, of course, these two bottom slots. Now, I've already got this on, so what I'm going to do is, and I've got it centered pretty much on the rod end, and I'm actually coming in here and looking down and making sure everything looks even. And I'm just going to attach this with some M8 bolts, and these are 16 millimeter long. They have a 6 millimeter hex on the other side. So I'm just going to kind of slide this down here, and I'm again looking straight down here. I can kind of see where these holes are lining up for this bracket, and I'll just get this first one started loosely. And you can actually reach the holes after you mount all this stuff to tighten down this aluminum CNC adapter, this up against here. So you don't have to worry about tightening this up first and then tightening this. So, which is a good thing because we still have a lot of flexibility. Let me go ahead and put the bottom one in here. As far as wiggling things around a little bit, just to get things to go in nice and easily. And we have one more. It's going in the middle. Everything seems to be cut well here as far as the screw holes and how they're matching up. And I'm going to go ahead and just kind of run these in a little to get the plate to mount flat. I'm not going to give a final torque on this yet, but just to flatten out the plate itself here against our CNC piece here, right? Just make it so it's going to line up exactly that way. and there's no doubt where it's going to be. And I'm going to do the same thing to the plate. Just going to get it to quit moving on me, but wait to do my final torque down once I have everything done. Now that we have this done, we need to put this bolt in. This is an M16 with a 2.0 pitch, massive bolt. You can see we have solid shank here, and that solid shank is going to be bearing the load of this yoke, the rod end rather, on this piece in here. So we're going to want to put this in here. Now at this point, all you have to do is you can grab the actuator and pull it in to where it needs to be. And I thought that was the best way to do it, instead of firing it up and trying to do it with by just manipulating it, which you can do, but it's a little bit jerky, or not jerky, it just doesn't ever stop where I want it to stop. But this way I can just kind of twist it a little bit as I pull on it. And as I'm doing that, I'm watching down here where these eyes are lining up, or rather the bushings. And then I'm going to take my bolt and see how good I did. And there it is. Pretty good. Oh, by the way, before you put this bolt in, you want to make sure you have the washer on this side. Then push it through. So that looks pretty good. Then we have this, obviously, lock washer that goes on the other side. And then we have the nylock nut that's going on this side. And there it is. So now all I have to do, obviously, is tighten all this down. It fit perfectly. So the machining and the measuring for a P1X is dead on here, which is awesome, because I thought, a lot of these things, they tend to not line up perfectly, and you have to do a little shimmying or something like that, but nothing here as far as that's concerned. This all came together quite well, and I think I can actually push this a little bit. There we go. So you guys can see how this goes. I'm going to extend it all the way. And that's the mechanical stop, which is not going to go this far in real life use, because we're going to have some buffer, like 5 millimeters for each end of these stops, like 10 millimeters total, because we don't want to hit the mechanical stops of the ball screw assemblies in these actuators. That would be very bad. They wouldn't last very long if we kept doing that. And we can push it the other way. And everything seems to be working pretty smoothly, and that's, again, why I'm doing this. Just testing it out a little bit to see how it works. And of course, I'm pulling against the actuator, so it's not going to be effortless to do it. All right, so yeah, I'm going to go ahead and torque all this down, and then when we come back, I'll probably just put it through a servo test loop, and then we can see how everything's moving, and that'll be job done as far as the build video. Remember, this is part 1, the build. I'm going to have part 2, which is the electronics, setting up the, attaching the servo drivers, wiring them up, cabling everything up, and taking a look at the PT actuator controller unit. That's the Thanos board that's inside of there. So that's, another video in itself. And then we're going to have a part 3 where I'm actually using it and tuning it in sim tools and giving my thoughts about how it performs. So here we are with the complete build. Everything is finished. Everything is wired up. And the surge, as you well know, if you've been watching this video, is the last thing that we did. And you can see that I have all of the bearing carriers bolted up now. And I might rearrange where these carriers are located. And once I get my uprights for the wheelbase mount on this P1X, then I'll know better where I want to put these. And it's easy enough just to loosen the bolts and slide them back and forth to where you need them to be. And you can see that I have them well short of the stops here. You can see the bolt sticking up there. Yeah, it doesn't even get close. And the same thing's happening over here on the back. You can see the bolt sticking up there, and we're not even getting close. Yeah, very good, very good. And yeah, everything's working great on the surge. There is some adjustment in this P1X chassis. You can loosen up the cross member corner brackets and tap it one way or another if you need to fine tune it so it fits in these carrier bearings well. And yeah, this is really working well. As you can see, it's very smooth. But listen, there is one thing on this that you guys have probably been hearing in the videos, especially if you guys have been following me on the Instagram. And that is, remember, we have a bearing in the traction loss actuator bracket down there, which allows it to, and you can watch it right here, it kind of swings through an arc. See how it moves? So you hear that little bump? That was not a problem or an issue or something loose. See how it swings over? Look how much that swings. That was the bearings, and wait for it to stop on the other end. Just a little teeny bit there. And what that is the bearing in there has some lash in it. Obviously, it has to be able to move, and that's what we're hearing. And it's louder on the fully extended stroke return right there because of more leverage, obviously, that is pulling back than when it's all the way retracted into the actuator housing. So, yeah, that is something easy to live with, especially considering, I mean, look at the arc, how much that actuator moves. That's a lot. And imagine if that was statically mounted and it could not move like that. Imagine the side loading on that actuator shaft coming in and out because of that. So yeah, very cool. And this is one of the tricker things that I like about this whole setup, the way PT Actuator did this. That is very cool. It's going to really take a lot of wear and tear out of your traction loss actuator, which of course is going to increase its life and performance. All right, surge actuator, no problems there. It's pushing out just like it should. Everything's parallel. Make sure, you got to make sure, obviously everything's parallel. You want to make sure you get your measurements, check them twice, and make sure there's no binding on the surge actuator. But other than that, yeah, it's just the usual stuff if you're going to be building a motion system. This was a complex build. It was not a difficult, what I would call a difficult build, but there's a lot of complexity to it. There's a lot of parts, in other words. You just have to take your time, be patient, and if you follow along on this video on the build, I don't see why anyone who is, handy with tools could not build one of these just by taking your time, checking everything twice, and yeah, just being patient and you'll get it done. Right, so that's it for the build part of this review on the PT Actuator 5 DOF system. Now remember, this is part 1. I will be having a part 2, which is all of the electronics and the cabling and all the things that go with that, building a little house around the drivers, all that stuff. And then part 3 is going to be where we get to have the most fun, and that is get in and start driving it and put it through its paces, tune it in sim tools, and also run some filters on that Thanos board that is in the PT Actuator controller box. So yeah, I'm going to call this done, and we'll just get to the final thoughts. Final thoughts on building the PT Actuator 5 DOF motion platform. As you can see from the length of this video, it is an involved process to build one of these kits. I would sum it up as a complex but not difficult build. There are a lot of things you need to get done here, but if you take your time and do your due diligence, I think most anyone who is handy with tools could get it done correctly. Now, the build quality of the parts and actuators from PT Actuator are what I feel like to be very good. From the assembly hardware to the industrial type parts, I feel like this assembly will be able to stand the test of time. Things like the heavy-duty pivot bearing and pivot pin, the custom traction loss actuator bracket that allows the actuator to follow the arc of the traction loss movement without binding, the quality aviation-style connectors with cabling to match. There are a lot of custom bracketry pieces that are made in-house at PT Actuator's factory, and with the exception of the surge bracket bolt clearance issue that I ran into, they all fit without dramas. The linear rails and carrier bearings in the kit seem to be of good quality and have a heavy-duty feel to them. Just what you want for parts that will be carrying a lot of the load here. Which brings us to the actuators that PT Actuator manufactures at their own factory. They are hands down the beefiest looking actuators I've had in the SRG to date. With 70mm diameter piston rod housings and 50mm piston rods, they give you the impression of being able to handle whatever you can throw at them. The brackets used to mount them are heavy steel units that are secured to the motion chassis with no less than 8 M8 bolts each, which follows a theme, I think, that I encountered throughout the build phase, and that is of being a very heavy-duty solid system here. I have had several people over to the SRG during the build process, and all of them, well, felt the same way. Now, this is part 1 of a 3-part series I'll be doing on the PT Actuator 5 DOF motion system. Part 2 will be covering all of the electronics, like wiring, cabling, and the controller hardware bits, with part 3 covering the configuration of the supporting software elements, and of course, real-time testing in the system under different driving disciplines. I'm Barry Rowland. Thanks again for watching the Sim Racing Garage channel. Don't forget to hit the subscribe button, and if you would like to help support what I do here at the SRG, visit my website at simracinggarage.com.